All right, hopefully a lot of these go really fast and they're really simple, and then some of them are a little more difficult and you'll have to work them out. So number one, what is the probability of randomly drawing a white? Half, 50%. And it makes it easier for me to check if everything's in a percentage. So on the test, do all of your answers in percentages. You don't need to change them on this, but if we all do the same one, then it will make my life easier. And some of them can't be written as fractions, at least not very easily. So 50%. 2, what is the probability of randomly drawing a 3? 50%. What is the probability of randomly drawing a white 1? 1 out of 6, which is like 16.6. And 4, what is the probability of drawing a 1 if you know that the ticket is black? 1/3. When drawing a single ticket, are color and number independent? No. Why not? So the ratios are not the same. You would need to point out one of the ratios that's not the same. So, yeah, there are no black 2s. So the probability of drawing a 3 is 1/2. But the probability of drawing a 3 if you know the card is white is 1/3. And because those are not the same, they are dependent. And there are a lot of ways you could explain that. What's the probability of drawing a 2? 1/6. What's the probability of drawing a 2 if you know the card is black? 0, and those don't match up. So in order for it to be independent, all of those ratios need to be the same. And they don't all have to be the same number, but when you introduce conditional probability, the original version and the conditional version need to be the same. Okay, next set of boxes. Number 6, what is the probability of randomly drawing a 2? 1/3. 7, what is the probability of randomly drawing a white 1? 1 out of 6. What is the probability of drawing a 1 if you know that the ticket is white? 1/3. When drawing a single ticket, are color and number independent? Yes. Why? Because all of the ratios match, meaning the probability of drawing a 1 is 33%. The probability of drawing a 1 if you know that the card is white or the card is black, they're all 1/3. And that's true for all of the numbers. Okay? 9 tickets are placed in a box as follows. Number 10, what is the probability of randomly drawing a black? 2/3, 66%. What is the probability of randomly drawing a 2? 5 out of 9. What is the probability of randomly drawing a black 1? 1/3. And what is the probability of drawing a 2 if you know that the ticket is black? 1/2. When drawing a single ticket, are color and number independent? No. Why not? What would we need to choose in order, or what would we need to change in order to make them independent? We could make a white 2 into a 1, or we could turn a black 1 into a 2. Okay, let me show you. All right, so independence deals with ratios and conditional probabilities. So the problem is 5/9 of the cards are 2s, but 2/3 of the white cards are 2s. And those don't match. So in this case, does drawing a 2 depend on the color of the card? Yes. If the card is black, then I have a 1/2 chance of drawing a 2. If the card is white, then I have a 2/3 chance of drawing a 2. Yeah. Does that make sense? So what could we do to this to make it independent? I could change this card to a 1. And now 2/3 of the cards are 1s, and 2/3 of the white cards are 1s, and 2/3 of the... Wait, that doesn't work, does it? I would need to do that. Is that better? Yes. So if I changed a white 2 to a 1 and a black 2 to a 1, now 2/3 of everything is a 1. Okay, how else could I change it? I could change one of the black ones to a 2, and now 2/3 of everything is a 2. 2/3 of the white, 2/3 of the black, and 2/3 of the total. Okay, and there are a lot of different ways to answer these questions. Just make sure that you give enough information that it's true. If you just say the ratios aren't the same, that's not going to be enough. Okay. So 3 draws are made at random from the box 3, 3, 4, 4, 4, 5, 5, 5. 15. If the draws are made with replacement, find the probability that 4 is drawn each time. Okay. Are these draws independent? Yes, because it's with replacement. So the second one does not depend on the first. What's the chance of drawing? So if they're independent, we use the multiplication rule. What's the chance of drawing a 4 on the first one? 3/8. And the second one is also 3/8 and 3/8. So 3 times 3 times 3 times 8 times 8 times 8. Oh, wait a minute. That doesn't work. 3 to the third. How about we divide by 8 to the third? That's a better idea. So 5%, 5.3%. Okay. 16. If the draws are made with replacement, find the probability that 3 is drawn first, 4 is drawn second, and 5 is drawn last. So the chance of drawing a 3 is 2/8, and then the chance of drawing a 4 is 3/8, and the chance of drawing a 5 is 3/8. So 2 times 3 times 3 divided by, I'll get it, 8 to the third, oh my goodness, divided by 8 to the third, holy cow, is 3.5%. Okay. 17. If the draws are made with replacement, find the probability of not drawing a 4 on any of the draws. So we could say that that would be 5/8 times 5/8 times 5/8. So 5 to the third divided by 8 to the third. And I get 24.4. Okay. 18. If the draws are made without replacement, find the probability that 5 is drawn each time. If I say without replacement, is this independent or dependent? It's dependent, and I can still use the multiply rule if I change the denominator and in some cases the numerator when I multiply. So what is the chance of drawing a 5 on the first draw? 3/8. Now I've pulled a 5 out. What's left in the box? There are now 7 cards, and only 2 of them are 5s. So for my next draw, I have 2 7ths. What's left in the box? 1 5 and 6 cards. So 1/6. So 3 times 2 divided by 8 divided by 7 divided by 6. And I get 1.79%. Okay, not very likely. 19. If the draws are made with replacement, find the probability that a 4 or a 5 is drawn each time. So what's the chance of winning on the first draw? 6 out of 8. Now, which card did I pull out? It could be a 4 or a 5. Does it matter? No. What's left in the box? So there are now, with replacement, so there's still 8 cards in the box, and there are still 6 4s or 5s. So that would be 6 over 8 times the next one, 6 over 8, and the next one would be 6 over 8. So 6 to the third divided by 8 to the third. 42%. Okay. Number 20, if the draws are made without replacement, find the probability that a 3 is drawn each time. So, first card I draw out is a 3. What's the chance of that? 2 out of 8. What's left in the box? There are now 7 cards, and one of them is a 3. So I draw that. What's the chance of drawing that 3? 1 out of 7. What's left in the box? No 3s and 6 cards. So what's the chance of drawing a 3? 0 out of 6. So the probability is 0. You can't do it. There aren't enough 3s in the box. If we were drawing with replacement, then it would work. 21. If the draws are made without replacement, find the probability that a 3 is drawn first, 4 is drawn second, and 5 is drawn last. Okay, so what's the chance of drawing a 3? 2 out of 8. What's left in the box? 7 cards, and 3 of them are 4s. So it would be 3 over 7. What's left in the box? 6 cards, and 3 of them are 5s. So 3 out of 5. 6. Sorry. So that's 618 divided by 8 divided by 7 divided by 6. 5.4%. If I rearranged the order, like the 5 first and then the 3 and then the 4, is that going to change the probability? It will in this case because it's with replacement, it's dependent, or without replacement, so it's dependent. We can switch the 4 and the 5, and that won't cause any problems. But if we move the 3s, then that's going to end up with a different answer. The denominator will always be the same, but the numerator will change. Wait, is that true? No, maybe not. Because we're still going to have 2s and 3s. No, I lied. It's not going to change because the multiplication can commute. So we can move those 2s and 3s around. And each ratio will be different, but the end result's going to be the same. I take it back. All right, what are we on? 22? If the draws are made with replacement, find the probability that 3 is drawn at least once. These are the hard ones. At least once is really hard to compute. So what do? We want at least 1 3. Instead, we calculate the probability of no 3s. And how do we do that? Well, we are drawing with replacement. What's the chance of not drawing a 3 on the first draw? 6 out of 8. We put the card back in, and we redraw. What's the chance of not getting a 3? 6 8. And then the next one will also be 6/8. So 6 to the third divided by, oh yeah, we just did this, didn't we? So we get 42.1%. That's not what we want. That's the chance of never drawing a, what are we on? 3. Okay? We want the chance that a 3 shows up. We don't care where it shows up. We don't care how often it shows up. If there's a 3, we win. So this number is the exact opposite of the probability of drawing at least 1 3. So we just take 100 and minus that, which is going to be 57.9%. Okay? Does anybody not understand that? There are 2 reasons why we do this. First, the addition rule gets complicated, and a lot of times they're not mutually exclusive, so the addition rule doesn't even work. And writing it out can be a huge pain, and you're likely to miss one. So instead, we turn it into an independence problem, and we multiply, and then we subtract from 100. Okay, 23. Same problem, but now we're drawing 4s instead of 3s. So what's the chance of not drawing a 4? 5/8 to the third, and I would just do that. 1 minus 5/8 to the third, and that will tell us our answer. So 1 minus 5/8. Oh, that doesn't work. 5/8 to the third. 75.6%. Yeah, I'm not too picky on that. Okay, we're changing the game. If 2 coins are flipped, what is the probability of getting exactly 1 head? 1/2. HT and TH. Okay. Getting exactly 2 tails. 1/4. Getting at least 1 tail. 3/4. So this one is simple enough. You don't need to do the backwards calculation. You could, but there are only 4 choices: TT, HH, TH, and HT. 3/4 of them have a T in them. Or you could say the probability of not getting a T is 1/4, which is the HH version, and subtract that from 1, you get 75%. Okay, 27. This one's tricky. Getting 2 heads if you know that one of the coins is a head. It's 1/3. Now you want to say 1/2, because if one is an H, then there's a 50% chance that the other one is an H. Why doesn't that work? Goat in the car problem? No, I think it's different. So we have HH, TH, HT, and TT. Okay, I flip the 2 coins and I tell you one of them is a heads. What does that do to my possibilities? It gets rid of the TT. So what's the chance that the other one is also a heads? 1/3. Right, that's good. So remember, whenever you flip coins or roll dice, you make them different colors or different types. So I flip a quarter and I flip a penny. If I tell you that the penny is heads, what's the chance that the quarter is heads? That would be 1/2. But if I tell you one of them is a heads, you're not sure which one it is. So if one of them is a heads, any one of those 3 is a possibility. And the chance that the other coin is the head is 1 out of 3. Okay? And those are a little bit confusing because they seem super simple when you look at them, but I didn't tell you which one was a head. Okay. Getting at least 1 tail if you know that one of the coins is a tail. So you have one that's a tail. What is the chance that you get one that has a tail? 100%. You already win. Yeah, that one's totally there to mess you up. It's super easy, but you have to be careful. You might say 2/3, right? Thinking or 1/3. Or, well, I guess you could mess it up both ways. Okay, 2 dice are rolled. What is the probability that the dice add up to 5? And I mentioned to somebody I'm going to put the chart up on the screen. I don't think I'm going to do that. Sorry, Parker. No, I think that makes this section way too easy because you can just count them. So you can draw it. You could draw your own table. Okay. So we're rolling 2 dice. And whenever you do this, just think you have a red dice and a blue dice. Okay? Keep them separate so that they're independent. All right, what is the chance that the dice add up to 5? Well, how can you add up to 5? You could have 1 and 4, so I'm just going to do 2-digit numbers, 14, or, so I'm going to do them in order, 23, 32, and 41, and there are 6 ways for the first dice to be rolled and 6 ways for the second, so I get 36 total. This is 4 out of 36, which is 1/9. So how many ways are there to roll the first dice? 6. And the second dice is 6. So there are 36 total possibilities. And 4 of those add up to 5. Okay? 1/9. Yep. 30. The dice do not show the same number. So let's say the first dice is a 1. How many possibilities are there to match with a 1? So they do not show the same numbers. So I have 1, 1, I have 12, 13, 14, 15, and 16. How many of those are winners? 5 out of the 6, right? So that one's out. On the next row, it would be 21, 22, 23, 24, 25, and 26. Which one of those doesn't count? 22. Do I need to write out the whole table? No, there are 5 wins per row, and there are a total of 6 rows, so 30 out of the entire 36. And again, if you need to draw out the table, go ahead and do it. Okay, 31. Getting at least 1 4. So in this table, where are the 4s? So there's a column of 4s right here. And there's also a row of 4s right there. So how many options have 4? Right, this column has 6 and this row has 6, so the answer is 12 out of 36. No, because you can't count that one twice. So it's actually 11 out of 36. Okay, are those two events mutually exclusive? No. If you get you get a 4 on the first one, does that mean you cannot get a 4 on the second one? No. So the addition rule doesn't work, and technically the addition rule does work, you just have to subtract off the intersection. Okay, 32. The number of dice is wow, let's try that again. The first number dice is exactly twice as big as the second. So can we roll a 1 and win with 1 being the first dice? So the first number dice is exactly twice as big as the second. 1 doesn't work. Okay? So 2, will 2 work? Yeah, 21. Will 3 work? No. Will 4 work? Yes, 4 and 2. Will 5 work? No. 6 and 3. So that's 3 out of 36, which is 1/12, and whatever that is as a decimal. Okay, and the second dice is a 4 or a 5. Do we care about the first dice? No. So how many ways are there to roll a 4 on the second dice? 6 ways, right? 1 4 1 or 1 4 2 4 3 4 5 4 and 6 4. So there's 6 of them. How many ways are there to get a 5 on the second dice? 6. Add those together. 12 out of 36. 1/3. Okay, we are ready for the test.